Okay, examples 3 and 4 are having us look at 32, 33, and 34 on our sheet in the backward sense. And this is leading us up to trigonometric identities involving these skills. So it's one of these skills I want you to be able to have. And it says in terms of a single trigonometric function. So if you take a look at this expression that we're looking at, which is rather lengthy, we have the ability to write that as just some trig function of some angle. So again, that's the power in this, is that we have the ability to take some complicated structure, maybe squish it into one nice little tiny compact structure. It's easier to work with. What I want you to look at on 32, 33, and 34, and if I write them correctly this time, we've got sine of x, cosine of y, plus or minus cosine of x, sine of y. You got cosine of x, cosine of y, minus plus sine of x, sine of y. And then you got tangent of x, plus or minus tangent of y, over 1 minus plus tangent of x times tangent of y. Okay, these are the structures we're going to be investigating here if we're going to try to write something in terms of a single trig function, and we're in the section involving sum and difference identities. We're looking for these structures in order to create one of the other things. And what I look for specifically is the layout of the trig function. So if I got sine, cosine, cosine, sine, that's this top one, right? And the top one tells me that we're looking at sine of x plus or minus y. And the x and the y that I'm dealing with, if you pay close attention to the structure of the expression over here, x is what we're taking the sine of, and y is what we're taking the cosine of on the first expression. Right? So if I need to identify the x and the y, that's the x and the y. So this is the x, that's the y in the sense of this expression. There's an x and y over here also. I could do it the same way, but some people feel like they have to do something with this term. They're like, I really need to do something with this term, but there's nothing to do. The structure creates this. We just have to identify what x and y are. So once I see the correct structure, it's this structure. So when I'm going to go to this, I just have to figure out what x and y are. X is 5x and y is 3x for the sake of what this expression looks like. So if I rewrite this thing, it's going to be sine parentheses. Plus minus means that the sign stays the same, so whatever the sign is up here is the sign that goes in here for sine. And then the first object is what x is, and we're calling that 5x, and the second object is what y is, that's 3x. So just like that, I transform what they've given me into a different structure. And then I just, if I combine my terms here, I get sine of 2x. So that expression is equivalent to this expression. All right. That being said, that's going to be some of your homework problems. It's going to be write this as a single trig expression. But that's also going to be a strategy in trig identities involved in this section. That this structure might come up in your problem. You'll have to transform it into this structure, maybe use that to go somewhere from there. So keep that in mind, that's where we're going with this, but there's going to be specific problems where it says just write this as a single trig function, just to really get you accustomed to seeing a structure and going back to a simpler structure.